Hello, everyone, and welcome back to another episode of MLOps Coffee Sessions. We have another exciting episode for all of you here today listening. I have Demetrios with me. Hey, Demetrios.
What's happening, everybody?
And with us today is Joel Grus. You all are very familiar with Joel. He is the author of Data Science from Scratch and is currently a principal engineer focused on machine learning at Capital Group with experience at the Allen Institute, Google, Microsoft, and many other places. But most famously, all of you will certainly have heard of him from his talk at an O'Reilly conference about I don't like notebooks. That prompted a lot of what many of us think today and question today about the value of notebooks. And we're very excited to dive deeper in with him about that and much more related to ML ops. Thanks for joining us, Joel.
Oh, thanks so much for having me.
So just to kind of kick things off, you were one of the earlier authors in the data science field with Data Science from Scratch, which became a Bible quickly. You gave an early talk that got us thinking about what are we really trying to do with notebooks. And so I kind of want to ask you just to start, how did you get into the data science and machine learning world pretty, to some degree, early on in its entire evolution? And how has your journey led you to where you are today?
Yeah, so I've had a pretty long, convoluted journey, but at a high level, I studied math, pure math, the kind that's not useful for much except proving theorems and coming up with conjectures and things like that. And I actually went to math grad school in a PhD program for a couple of years until I dropped out. And this was way before data science. And so at the time, if you studied math, the thing to do was quantitative finance. So I kind of got into quantitative finance, options pricing, financial risk, things like that, and spent a few years working in that field. But I never really liked it that much. And so I was working at a hedge fund, let's say 2006, that sort of flamed out kind of spectacularly. And I found myself with nothing to do. And I didn't really want to get back into the finance world. And so I was sort of at this turning point. And through the magic of cronyism, I landed kind of a business intelligence role at a startup called Faircast, which was an online travel site where the special sauce was that they did price predictions on airfares. So we think that the lowest fare, or we know that the lowest fare is $200 for your trip, and we predict it's going up, so you should buy now. Or we think the price is going down, so you'd be better off waiting. So my job there was not machine learning. It was not anything like that. It was writing SQL queries and building spreadsheets and making pivot tables. And so there are a lot of SQL queries that need to be written, and doing things like how correct are our predictions and how do they affect our customers, things like that. So it's kind of a very light data analysis, data science type role. We were doing machine learning, but we didn't even call the people who did machine learning MLEs or data scientists. We call them data miners. And they all had PhDs in computer science, and they had basically built out all of their own machine learning toolkits in C++ to run on a Sun grid engine. So it was sort of a different time. And so I was there for a few years. It got acquired by Microsoft, and I was there for a few years as well. And then around, 2011, I was still asking, what do I really want to be doing? And data science was just starting to become a thing. And so I thought, that seems very similar to what I've been doing and what I enjoy. And so I'm going to try and move myself in that direction. In 2011, it sounds comical now, but the way to become a data scientist was basically to call yourself a data scientist, and then you were one. And so, my first actual data science job, I went in it for an interview. This was at a startup. I was the second employee. The CEO brought in a printout of a SQL query and showed it to me and said, "Do you understand this?" And I looked at it and I said, yes, I do. And he's like, "Okay, you're hired." So obviously that's not how data science interviews work today, but that's how they worked back then. And so, I led data science at a startup called Volumetrics.
Wow.
I was there for about 3 years. It was really interesting. Another slice of the time story is that around 2012, I wanted to hire some junior data scientists to help me out. And so I put it out on Craigslist. I guess Craigslist was the way to hire people then. I don't think it is anymore. But they basically said, I want to hire a junior data scientist, must know some math, no experience required. And it's the hardest time finding candidates. And today, if you put a sign like that out there, you'd be trampled. But I just had the hardest time finding people who were interested and wanted to apply. So, obviously things have changed over then. Volumetrics was a company that did analytics on enterprise collaboration data. So looking at who emails who meets with whom, how often, what topics, and using that to produce reports and analytics about how well the company is functioning, how are people spending their time on the right things like that. And so there, the data science was the project, or was the product. And so because of that, I ended up writing a lot of code that went into the product, which was probably not a great thing for the company, but I found that I really liked it. And so I decided that I wanted to learn more about, writing good code and how to build software and things like that. So I did another kind of pivot into software engineering, went to Google, where, I was just not a data scientist, not a machine learning person, just a pure software engineer. And I did that for a couple of years, and I learned a ton, and it was super boring. And so then again, I left and I went to the Allen Institute, where I kind of found a role as a research engineer, which was sort of like really sitting at the intersection of software engineering and machine learning. So it was my job to make sure that the researchers were actually like writing good code, and that they were implementing their models correctly, and that they were, doing good experiments. And so that's a little bit where I kind of got the bug for, why data scientists and why machine learning people should really care about software engineering best practices, which has kind of been, obviously a theme of mine for the past 5 years or so. And so, I spent about 4 years there. I helped design and build the Allen NLP library for doing deep learning and NLP. And then about 2 years ago, I left and joined Capital Group, where I lead a team that focuses again on machine learning, NLP, AI type stuff related to the investment process. So
That is one hell of an intro, bio, background, everything. Wow. Yeah. It's not every day that we get such a colorful, it seems like you've done it all. And I love what you were talking about in, what was it, 2011, 2012. The way to become a data scientist was just to call yourself a data scientist. I think we're going to probably make a quote out of that one. And also that you were looking
Well, I
for
think
candidates on Craigslist.
yeah, it sounds a lot like what it's like to be a machine learning engineer in like 2017. Just call yourself a machine learning engineer, and now in 2021 and 2022, call yourself an MLOps engineer, right?
Yep.
exactly.
Just
That's the way to do
learn,
it.
just selling smoke. Yeah. So there's one thing that I wanted to get to, unless Vishnu has any questions that he wants to follow up on when it comes to your bio and all of that. But I think we could probably dive right in to the way that I found you first, was through the infamous talk, like, that you gave. You went to I thought you went to the Pi Data conference,
No, it was
or
JupyterCon.
JupyterCon, yeah,
JupyterCon. That's it. And you gave a talk
in the
on
belly of
why
the beast.
the cojones on this guy. All right, that is amazing. So, would you still give that talk today, being that there's been a lot of tools that have come out to try and solve the problem that you raised?
I wouldn't give the same talk, but I would give sort of an updated version of it. Certainly, yeah. It's a funny story how that talk came about as well. So when I joined Allen Institute for Artificial Intelligence, we were mostly doing natural language processing stuff, and so at the time, in let's say 2016, Stanford Core NLP was sort of the big NLP library, and that was in Java. And so because of that, AI2 was a Scala shop. And I was historically more of a Python person, but I can do Scala when someone makes me. But then after I'd been there a year and a half, suddenly the NLP community like turned on a dime and started doing deep learning, and suddenly it was all TensorFlow and PyTorch, and in particular it was all Python. And so now it's sort of like, don't skate to where the puck is, skate to where the puck is going to be. Well, the puck was going to be in Python. And so like suddenly I was in high demand within the organization. Like, oh, Joel knows a lot of Python. Let's get him to, help everyone out who has to make the switch from Scala to Python. So I was helping someone out, a really senior, really smart software engineer. And she came to me and she said, I'm so confused by Python. Like, I don't get it. Like, I'm having so many problems. And I don't understand it. Can you help me? So she came to me. And I had never really thought much about notebooks before this. And I said, show me what you did. And she brought me this Jupyter notebook that she'd been messing around in. And it turned out that every one of her problems were not caused by Python, were not caused by her misunderstanding of Python, but they were caused by the hidden state in the notebook, and that she'd basically gotten it into a place where she was not able to reason about like what her variables had in them, what her code was doing. And so, here we have a super, like a really smart person, like a really talented engineer, who's just like gotten completely confused because of features that are intrinsic to Jupyter notebooks. And so, I went on Twitter, I go on Twitter, and I was frustrated kind of on her behalf. And so I made sort of a very intemperate tweet about how, if anyone wants me to give a talk about like how notebooks are bad and no one should ever use them, please invite me because I would love an excuse to write it. And someone at JupyterCon saw the tweet and they tweeted back and said, basically, we're not above criticism. So, if you submit a proposal, we'll consider it. And then I was like, okay, I'm not really going to do this, but, someone kind of talked me into it right before the deadline. So I submitted a proposal, and then they accepted it. And then I was like, oh gosh, this is the belly of the beast, right? So now I'm going to go into a conference for people who are enthusiasts about something and tell them why I don't like that thing. And here's all the problems with that thing. And so I thought,
So
if I'm going to
amazing.
do this, I better have my ducks in a row. So I better make sure that one, I've thought of every like criticism that's important to me, and two, I better make sure that those aren't things that are actually addressed and I'm not just being dumb for not knowing how to solve them. So I actually spent like an enormous amount of time researching and writing that talk, probably more time than I've ever spent on a talk. And then I went there and I gave it, and it was, I think it was mostly fair, right? Like, so yes, it was kind of a polemic, and yes, I made it funny and everything, but I do feel like my criticisms were fair and were reasonable, and so because of that, I think, I think a couple things happened. One, it was reasonably okay received at the conference, and two, what happened, and I feel a little bit bad about this, is it caused a little bit of a preference cascade, where it turned out there are a lot of people who never liked notebooks, but they never said anything because they thought they were the only one. And then all these people, some of them like really prominent in the data science community, came out when my talk got published, and they're like, "Oh yeah, I agree with this. I don't like notebooks either." And I think the Jupyter people who are all very nice. I think they were a little bit taken aback by all these people kind of coming out of the woodwork all at once and sort of like joining in this pylon. So I do feel bad about that, but
They didn't throw tomatoes at you though, and they didn't boo you off the stage. So that's a
they did
success.
not. Yeah.
Yeah, I mean, I certainly think that the talk was, more than fair, hilarious, but also more than fair. It was, you talked about, the reality of why they're useful. They have the interactivity, they present a low lift, to get started with something. But you're right. The more you use them, the paradox is the more difficult they get to use, in a sense, right? Because of that hidden state and because of the, line by line execution and all those things that complicate the process of working with notebooks. So you gave that talk in 2018, and it was quite interesting. And now we are 3 years later, and sometimes it feels like the conversation hasn't really moved that far past it. In our community, a lot of times we have long threads from people all over the world saying, okay, we're at the point, we have a couple data scientists, they're all in notebooks, but we want to start, scheduling jobs and create a more sophisticated machine learning process. It's funny how that happened a few years ago, but we're still in the overall, I guess, zeitgeist, still at the same point. Would you agree with that sort of discussion, or have you seen work that makes you feel that maybe we have better tooling around notebooks that people could take better advantage of?
So there's a couple things. There is some better tooling that make things like code review and source control and things like that easier. Do they remove all the friction there, or do they remove enough friction there? That I'm not sure. but certainly, people are trying to address like some of the problems I called out. At the same time, people are also trying to invent around this, right? So, one use case that was prominent for notebooks is, hey, I want to give someone a way to interactively, play with this model, right? Well, now we have other tools like Streamlit, where you can, here I'm just going to, write some Python code and it's going to give me a web app that exposes my model. And then I don't even have to mess with notebooks. And if my goal of using a notebook was to give people an interactive way of seeing how this model works or feeding it inputs or things like that, then I don't need notebooks for that. Similarly, I apologize, I forgot the name of the company, but I saw them recently, and they basically developed what was kind of a notebook alternative. It's still a notebook, I think, but it uses a fully reactive kernel. So what that means is it builds a DAG, directed acyclic graph of all its cells, right? And so when you change a cell, it knows what cells depend on that cell, and it automatically updates them. So there's no way, and I can look it up afterwards and hopefully find them. I haven't tried it, but I saw them on Twitter. But then that, mostly eliminates the hidden state problem in that if you change a value somewhere, everything that it depends on changes. And in fact, when I was at JupyterCon, there was they had a poster session, and someone at the poster session had basically, as an experiment, built a fully reactive kernel for Jupyter, where when you made a change to a cell, it would basically rerun the notebook, from that point on. And I tried to get them to bite the bullet that that's how notebooks should work, and they didn't agree with me. But
Yeah, was that tool Hex?
that sounds right.
Yeah, I think it might be Hex. Hex is cool. Hex is really cool. And I really agree with your point, I think, around, and I like the way you framed it, which is that other tools are coming in to address, almost, you could call it unbundling the notebook, right? Like all the things that we do with the notebook, you can pull it out. I know Demetrius knows that this is a favorite phrase of mine, unbundling the X thing. And makes a lot of sense when you put it that way. One question that I kind of have is, we right now in the overall data engineering and data science world, it feels like we're going through a little bit of a step function evolution, in the sense that there's this idea of the modern data stack. More consumers of data exist in organizations than before. So there are tools like High Touch and other tools that I'm not even familiar with, that are taking data outside of the centralized data team and making it available more easily than ever before. We have new sort of like data engineering tools that are helping with orchestration. And then you also have data tools that are helping with the more intensive workflows like machine learning, right? And I say all of this to kind of say and kind of get your perspective on, as somebody that has been at sort of every step of the data science journey, right? You've done business intelligence, you've done data science, you've done software engineering, and now you're doing machine learning engineering. Where do you think, some of the most interesting greenfield opportunities are in the context of this new data stack, right? Like, what are the things that are really interesting to you in your current job right now?
So I'm in a bit of a funny spot in my current job in that my organization, one, we're really all in on AWS, and two, because we're a financial, investments company, we're extremely security conscious. Um, and so because of that, I don't have as many opportunities as I would if I were at a startup to sort of like take a broad look and say what is the best tool out there for my problem. I'm relatively more constrained to what are the tools that the security team has uh, has said that we're allowed to use, basically, and that tends to be very standard AWS type stuff. So that means that we have a lot of workflows within my team that are really based off of Lambda functions, Sagemaker endpoints, message queues, things like that, that are like on one hand they're bespoke, and on the other hand they're bespoke using relatively standard like platform as a service pieces. And so, that's most of what my team has been doing from a kind of data engineering / MLOps perspective. And so I have this sense that there's like all this great stuff out there, and it's sort of, a world that's not available to me today.
No, I totally feel that. I work at a GCP shop. We're completely built on top of it, and it's nice actually to sit within a particular tool stack and kind of feel like, okay, this is my world, it's my island, and there's ocean all out there, but I can't swim yet.
Yep.
And it does help with speed a lot. And in that context, you guys are leveraging AWS heavily. You mentioned Lambda, SageMaker, etc. I kind of want to zoom in on this idea of MLOps in particular, right? How your company is practicing MLOps, and one thing that you mentioned, in your focus areas for your job right now is that you focus a lot on building your team and nurturing talent. So, how do you think about the different kinds of professionals that are required for your organization to practice MLOps?
Yeah, so I'm in a little bit of a funny spot, and that I was hired in to basically bring machine learning to a part of the organization that was, modulo this AWS restriction, relatively greenfield from a technology perspective, but also not really doing much in the ML space. So that meant that, any ML ops that I needed, for the most part, I had to invent or build as I went. It wasn't there waiting for me. So now I have a team of me and 4 other people. Things are really kind of broken out, a little bit more siloed than I'd like. I have one person who's a real expert on AWS stuff and AWS infrastructure, how to build things in AWS. I have one person who's very, NLP savvy and knows a lot about how to, train and use NLP models. I have one person who has a very deep experience in search and search relevance, and Elasticsearch, and so he works on a lot of that stuff. And then I have one more junior person who is sort of trying to learn all across that stack, and then I also sort of, have to learn all across that stack. So, I would love to cross train them more, but I think, given the state I'm in, I very heavily need the AWS expert to tell me, this is how we should be architecting this one piece of our stack and so on. But, really, I've been at Capital for about 2 years, and really a lot of those 2 years have been spent just building out relatively simple infrastructure, so that we're finally in a position where now we can train models, we can deploy models, we can serve models, things like that. But there was like a lot of investment around, both data engineering as well as the MLOps side of, how do we, once we've trained a model, how do we deploy it, how do we monitor it, et cetera, et cetera.
How did you go about evaluating that? Because I know a lot of people that come into the community are in that stage more or less, or maybe a little more advanced, but the evaluation process is super difficult, right? Like finding out what's the best for your use case, just trying to figure out what the landscape looks like and how to go about it. Was it again like, hey, well, we're constrained to using AWS, so we're just going to use what we've got, and we have a few conversations with the DevSecOps guys, and they say this is what you can use, this is what you can't use, or what did you do?
That's really pretty close to the truth. I mean, the basic setting is that, we have a bunch of data sitting in S3 somewhere, and we need to take that raw data and process it into a form we can use. Okay, well, that's pre-processing is going to be, with a Lambda function, and so we need to set up notifications so that we know when there's more data to transform it. And then, okay, now we want to train a machine learning model on it. Well, basically, the security people said, if you want to train a machine learning model, your choices are Sagemaker and Sagemaker. So that made it real easy. And I actually so Sagemaker has an API where they have a bunch of algorithms, and it's not the way I like to work. They also have they call it bring your own algorithm, where you supply them a Docker image that corresponds to a not heavily documented spec, but it needs to, do certain things and serve certain things at certain ports and respond to certain data in certain ways. So we spent, a big chunk of time, reverse engineering that, and then, coming up with some abstractions that allowed us to fit our workflows into that model. And then, yeah, I mean, right now we're looking into the Sagemaker has this Sagemaker feature store. So someone on my team is evaluating that, and hopefully that will work for our needs, and we'll implement that as well.
Actually, that's funny that you say that just before I see Vishnu wants to jump in, but there is something to be said for that. And now I just forgot what I was going to say because I thought about Vishnu how I cut Vishnu off. All right, well, Vishnu, you go ahead, and then if I can remember what I was going to say, I'll say it later.
I
Is it
hope
about the Sagemaker bring your own algorithm?
Yeah, yeah, that's it. So it was just a quick comment on how SageMaker can get you. We've heard this quite a bit. It can get you 80% of the way there, but then if you ever want to tinker with things, you end up taking so long to try and make that extra 5 or 10% that you're trying to get out of it really work. Has that been your experience too?
No, but only because of the way I approached it, right? Like I said, I looked at the SageMaker inference API and said, I don't feel comfortable assuming that every model I'm ever going to want to use fits into that API, right? So therefore, I don't want to couple myself to that API. So therefore, I am going to use this bring your own algorithm mode from the start. And basically, once I figured out how that mode works, because again, it wasn't like perfectly documented, for the most part, I haven't felt like it's constrained the way we do things. I mean, it's constrained the way we do things, but I don't think there's like an extra 20% that we can't get to because of SageMaker. It's more that we had to spend a lot of time up front, basically fitting our work into that bring your own algorithm mode. And now that we've done that, it's not that different from, if I had a bare EC2 instance and I was just writing my own code anyway. I just need to, respect one, here is what the machine that runs your Docker image is going to call it with, and two, here is the format in which data is going to be fed into your training algorithm, basically.
Yeah, that is a really interesting point. And what I want to flag there is that, and I'm assuming, you correct me if I'm wrong, that this came from your experiences at the Allen Institute as a research engineer and potentially even Google, but you understood upfront that the first model that we're going to build is not our last. Therefore, how we go about the process of building out our machine learning platform and process needs to support kind of it needs to be flexible, right? Because I think in my experience, what some of the traps I've gotten caught up in is you're rushing to push out your first model. You end up taking some bad practices in terms of code review or using notebooks a little bit too aggressively, and then you kind of look back and you're like, well, damn, we can't really use that code as much as we want to, and it's not as flexible as we thought. Is my surmise there correct?
Yeah, so I would say less Google, but more AI too. So there's a couple things going on there. One is that if you ever look at the Allen NLP library, which, as I mentioned, is a deep learning library for doing NLP, it's a very opinionated library, and it enforces a certain structure on your code. And so that really shaped the way that I think about writing machine learning code and designing machine learning experiments. And so this library we built, it's called Sagemaker because it's the Capital Group library on top of SageMaker. That's a clever naming thing that I did.
Nice.
But anyway, this Sagemaker library, it basically, if you looked at it, you say, oh, that looks like Allen NLP in some ways. It has some of the same abstractions and it represents the same sort of thinking. So, that was one piece. The second piece, which is also a big thing, from Allen NLP, is that when I am starting with a new kind of model, I want to iterate quickly. And I want to iterate quickly basically by training it locally against a very small data set, right? So, if I have a data set with 10 examples and I train my model on that locally and it trains, then I can feel confident that, okay, my model's doing the right thing. It's dealing with data correctly and so on. And then I can go off and say, hey, cloud, run this against this giant data set. And that's a much faster and safer way for me to sort of iterate and experiment than if, I type some code, build a Docker image, run it in the cloud. Okay, there's a syntax error, like whatever. And so the other thing that I thought is that and it's possible that there's solutions to this that I don't know about, but I thought if I'm using these, SageMaker APIs that are basically, SageMaker.classifier.train or whatever, can I actually run these locally as easily as I can run them, in the cloud? And I didn't see a way to do that. It's possible I didn't look hard enough. And so this other method where basically I have a Docker image that encapsulates the training of my model, well, I can run Docker images locally. I can run them in SageMaker. I could even, in theory, run them on an EC2 instance. And so that gives me a little bit more flexibility to, iterate on small data sets locally. And so that was also something that was important as part of the design process.
So I'm going to change gears here real fast and ask you, considering your experience and where you're working now, do you have any hot takes on the data science world or data scientists as we see them in the year 2021?
Any hot takes? I don't know. It seems like everyone wants to be a data scientist now. It's sort of amazing to me that there's colleges that you can major in data science because, here's this field that didn't exist 10 years ago and that I don't really think of as a academic field, but, now there's a department of data science, there's master's degrees in data science. And, if I wanted to be really cynical, I would look at those as, mostly money grabs. But even if I didn't want to be cynical, I probably would as well. But no, I think, I'm not in the camp of people who think that, gosh, data science is just going to be automated away and there's no room for people to do this. I think there's always going to be room for people to do this. At the same time, what are the skills that are going to be needed? A long time ago, probably 5, 6, 7 years ago, I was very explicit that I thought that data science as a standalone field was going to go away, and that essentially what we now call machine learning engineers was going to kind of subsume the field. I think I was wrong about that. It hasn't happened, and I don't really see much sign of it happening. If anything, it's kind of split into two different things. So I think there'll always be a need for data scientists, but I do believe that data scientists should try and be more like software engineers. I do think that data scientists should think of their code as production code, and that there is a lot they can learn from software engineering best practices. And so because of that, I'm personally skeptical of data scientists who don't think of themselves that way. I have this joke, the data scientist who says, I'm not writing production code. This is just, code for, doing analytics. I said, what are the analytics for? And they said, oh, well, they're used to make business decisions. I said, okay, well, that sounds a lot like production code to me, because you're basically, shipping a decision to, your business. So yeah, so that's maybe my hottest take, but it's also an old take, because I've been saying that for years.
Still useful to get your thoughts on it. I think that there are a lot of people, maybe stemming from some of the discussion about notebooks and data science tooling in general, who think that, data science will be automated away, or that, that the profession as a whole is not really as important. But it's good to get your thoughts that, it is still. And I agree, because, that intuition around data, the research, the digging into it, that'll never really go away, as many, automated model training things as we see. And with that, I kind of wanted to ask more about MLOps in particular. And, my question kind of stems from, over the past 5 years, the process of going from data to model in production has really changed a lot. With this, the profession of machine learning engineer has really risen in terms of frequency. We see a lot more ML engineers now That position kind of has its own niche, right? Which is being that intersection between software engineering and data science that you talked about. Now we're seeing another profession in the sense of an MLOps engineer whose job almost is to, once that model is in production, to keep that model in production, right? And to keep new models coming in and to ultimately allow increased velocity around new models in production. My question to you is, where do you think we're at right now in terms of overall maturity in the MLOps field? And where do you think some of the most glaring challenges are, where better tooling or process could really help an organization like yours or another?
So one, I don't, well, speaking for my team, we're definitely not very mature in terms of our thinking around this. I think there are opportunities, but I think part of the challenge is that some of these things are really judgment based. In other words, okay, I've deployed a model, now I want to somehow track, what kind of predictions is it making in production, and at what point, does it need to be retrained? Well, that depends, right? And to know when it needs to be retrained or replaced or decommissioned or whatever really requires understanding what is the business problem this model is solving, and what kind of errors is it making, and how would a newer model do. And so on one hand you can think of tooling and stuff to help with that, and it exists, but at the same time I don't think it's a problem you're ever going to be able to completely tool your way out of. And so my team, we're not even to that point yet, right? We're still at the point of we need to get these models out there and being used, and then once they're there, then we can start asking some of these kinds of questions. But yeah, I mean, the other thing is that I have a small team, and once we start putting models in production, then I guess we owe someone an SLA, and we're committed to keeping these models running. And how do we make sure that they do? And that's another thing that I'm starting to think about, because we're getting close to that, and I don't think we want to be carrying pagers 24/7. There's not very many of us, but I imagine we probably will be.
Yeah, no, I think that makes sense. And it leads me, now that you mentioned where your team is at and what kinds of things you're starting to think about, I'd love to talk a little bit more about the kinds of problems in NLP and search that you are trying to solve from a data science and machine learning standpoint. I recently joined an NLP company, and it has been really interesting to be in this sort of subfield at a time when there's so much going on, right? With transformer networks, Hugging Face, like all kinds of new tools coming out to work specifically with NLP, which can be a little bit more unstructured. Can you give us a little bit of perspective on what kinds of problems you're trying to solve in the NLP and search realm at Capital Group?
Yeah, so Capital Group is a big 90-year-old company, and the investment process is really based around deep fundamental research and long-term investing. And so the way that manifests is that you have these portfolio managers and analysts who are really seeking to deeply understand companies and industries and politics and economics, and talking to management and talking to customers, and really trying to deeply understand the world. And so that that manifests in terms of a lot of written research, and so it's a culture of I'm going to write down today my thoughts on the auto ML industry, and then I'm going to share them with people, and then people will comment and we'll discuss them, and so on. So there's this real culture of research and discussion around and especially in particular written research. And so my team, it's not the only thing we do, but one thing that we spend a lot of time thinking about is search and NLP tools around this corpus of internal research. How do we make it easier for people to find the research they're looking for? How do we make it easier for people to get find the relevant parts of a research document? How do we make it easier for people to share and so on and so forth? And so because of that, it's a lot of really standard type applications around things like named entity recognition, text classification, automated summarization, so on and so forth. Search relevance.
Yeah, that makes sense. I think one of the things that I've realized in my short time in NLP already has been that, you know, you have this sort of initially unstructured corpus of data, and a lot of the initial challenge is finding ways to put structures on it, right? In our case with clinical notes, we spend a lot of time thinking about subheadings, different types of data within the text, right? A lab value as opposed to some kind of clinical jargon. And it sounds like that's probably an approach that your team takes as well a lot too, right?
Less with the particular structure, because there tends to be a wide variety in the structure of the documents and it changes over time. But yes, in terms of, here's like a bunch of text and sentences and images and stuff, and how do we extract from that sort of meaning or the things we're trying to find.
Got it. So a challenge that I've seen many companies face, not just in NLP, has been, with the probabilistic nature of machine learning systems, as data changes, how do you keep your model iterations and just your models fresh, right? Yep. How do you approach that problem right now at Capital Group? I know you mentioned that you're looking at, what the future of your MLOps process is, but at this stage, where are you guys at right now with that challenge?
I would say right now we're at the stage of pretending like that challenge doesn't exist. So, but to be fair, if you think about think about named entity recognition, right? And I want to tell whether something is a company in a sense, let's say, right? Then assuming your training data represents a reasonably representative sample over a long period of time, it's not really the case that the way people talk about companies is that different today than it was, 20 years ago. Like either way, if they say I met with the management of blank, the patterns are similar. The company names may be different, but I think given the way that most of these models take context into account now, I don't think you get that much drift in that sort of model. And similarly for some of the other things, right? I don't do really sentiment analysis, but you think about like sentiment analysis, right? Yes, like language changes over time, but at the same time, if you train a sentiment analysis model over the past 20 years, then it's probably going to do okay over the next year. It's not like you're going to be like, oh gosh, people express positivity in a completely different way now than they did. I mean, it does change and slang does change, but I think some of these NLP phenomena maybe change a lot less than if you were trying to do mining of like customer behavior or things like that.
So there is this theme, as you mentioned earlier, in your life, and it is the production code and best practices, making sure that you infuse those into everything you're doing. And like you said earlier, a data scientist should be ready to write production code, and they can't cop out by saying that this isn't production, this isn't going to production or any of that. I wonder, because of one of the Slack channels that we have in the community Slack that is probably the most active is our production code Slack channel. And we talk all about the different ways that you can approach machine learning and how you need to have so many different things in mind when you are putting out a model. And especially if you're coming from the data scientist background, which you came from. You went from a data scientist to a software engineer afterwards. Well, I mean, I don't think you called it a data scientist, but it was basically that, right? And
no, I did call it a data scientist. Before I was a software engineer, my title was actually data scientist. So,
all right, that you gave to yourself.
Yes, exactly.
Yeah,
but that's what it said on my business card. So,
no, nice. So it was true. So basically, what I'm wondering about is, let's imagine a data scientist comes to work with you, and I can suppose that this has happened before, and you want to instill these best practices into them. What are you telling the data scientists? Like, what are the things that you're saying besides, hey, write production code, but what does that mean? And how can they go deeper on that? Especially for those that are coming at machine learning and MLOps, like so many that I talk to in the community from the data science background.
So this is something that I picked up from Google and then have carried through ever since. But I'm extremely serious about code review. So like, I don't care what you're doing on my team. It gets code reviewed before it gets, checked in, right? And so especially with, either junior people or people who maybe are coming from a tradition that doesn't think about writing software that way. Code review is a way for me to, basically show you, hey, here, I wouldn't have written it this way. Here's why. And so I actually spend quite a bit of time doing code reviews. I think they're super valuable, and they're sort of my number one way for getting people to, buy into this line of thinking. It's funny. I had someone who joined my team shortly after I joined Capital Group, and for the first year he was on my team, I was giving him like really serious code reviews, like, no, don't do this, do it this way, et cetera, et cetera. And like after a year of that, he basically had internalized my voice. And so he thought, oh, I was going to do it this way, but I thought you wouldn't like that. So I did it like the right way. I'm like, yeah.
Yeah, code review is invaluable. And actually, I have a couple questions about how you guys do it. Number one, we asked a lot about what you think about notebooks, but are you using notebooks at Capital Group in your team?
Not for anything that gets checked into source control. No.
Okay.
We are, unfortunately, because for some really stupid reasons, that basically it's very difficult for me to set up an EC2 instance, or it was for a long time. It was very difficult for me to set up a bare EC2 instance, and so the only real way for me to get elastic compute was by using a Sagemaker notebooks instance. And so because of that, we ended up using Sagemaker notebooks instances for a lot of stuff. And you can write in a little text editor there and so on. It's not a great experience, but we're trying to move away from that.
Okay, no, that makes sense. I've been there with the SageMaker notebook deal. Okay, so you're not using notebooks as part of your source control. So everything is in, Python scripts and kind of set up that way. Are you guys following like, some kind of like common repo structure that you use for all projects?
No, not really. We kind of take it on an ad hoc basis. We probably should, but as for now, it's sort of anything goes. Each repo has kind of its own structure.
Okay, cool. And in terms of who reviews what code, is it everyone reviews kind of like everyone's code, or is it like, is it primarily that you're reviewing your reports code? Like, how does that work?
I think what happens is that when people are new to the team, I end up doing a lot of their code reviews. Obviously, like when I say everyone's code gets reviewed, everyone's code gets reviewed. So, early on, it was me and this very junior person on my team. And when I wrote code, he had to review it because there's no one else to review it, right? And he learned stuff that way too. But I don't get to check stuff in without a code review because the rules for everyone. But I think the problem has been, and I mentioned this earlier, that my team has ended up working in a very siloed way. In that here's one person who's working on mostly MLOps stuff. Here's one person who's working mostly on search stuff, and so because of that, I have been kind of the most natural code reviewer for each of those because I'm the one person who sees across all of them. I would rather that not be the case, and so I'm trying to get to a point where other people can be doing the code reviews because I got other stuff to do.
That was actually something that someone mentioned to me when we were talking about, because one of the channels in the MLOps community is like coding pals. And the idea there is that you get matched up randomly with other people in the channel and you have a code review. And someone told me like, yeah, but if you don't know the problem they're working on and you don't really know the use case, it's really hard to review someone else's code. And maybe I'm used to working with this and they're working in that. And so it's really difficult. And so I could see that, like, these little islands of knowledge, and how do you bridge those gaps in your company with the code pals? That's just a whole nother level. So
I think there's two things there, right? There's one thing, which is, if you give me some Python code, regardless of what it's doing, I can tell you, oh gosh, you should have used a list comprehension here, or oh gosh, you should not have used a default, a mutable default value for your function argument, or things like that. So there is a lot I can do in terms of just making things cleaner and more idiomatic and finding sort of obvious bugs. But you're right that, as things get more either domain specific, or you're coding against an API I don't know, or using some library that I'm not familiar with, then suddenly I can't be as helpful.
Yeah, I think the way I break it up in my head is there's style and function, right? And the initial code review is it's easy to do style, and it's always helpful, right? Because style lends itself to readability, and then function is that's kind of what the problem is, and that's a little bit more context dependent.
Yeah, but I would rather outsource style. What I mean is this. So I'll use black for formatting because I don't want to get into formatting. I don't want to think about formatting. Black can worry about formatting. That's that. And then I'm going to use Flake8 to check for style stuff. I don't use Pilot. I have some gripes with Pilot, but we don't need to talk about them. But and so I want Black and Flake8 to like take care of as much as they can, right? And then my code review is not about style. It's about unless you consider like idiomatic stuff style, in which case it is a little bit about that. But it's also just about, it's more about readability, actually. Like that's the other thing is that I took away from Google is being like hyper focused on readability. And so a lot of my code review are not even this is wrong, or this is an incorrect way to write it, but it's like, I don't like this function name because it doesn't actually tell you what the function's doing. I wouldn't call the variable this, I would call this other thing, because it would make your code 10 times easier to understand. I would not write this loop this way because it's super convoluted. I would write this other way because this would make it much clearer what it's actually doing. And so a huge number of my code review comments are really that flavor, right? Like, I get what you're doing. Here's how you can make it 10 times more clear and understandable, so that when you come back to this in a month, or when I come back to it in a month, like we understand what it's doing.
I will say, that makes a ton of sense. And what I will say as somebody that's, a little bit more junior and is on my way and still getting a lot of code review comments is, you got to just put it out there, right? And you got to accept that code review as a cultural value for your team is about getting the best product out and using that as a way of learning. That's the way to actually, I find, to leverage code review the right way. It's not to just look at a finished product and check it in, right? And the less comments you get, the better. Actually, maybe do it a little bit earlier so that you can actually get the comments, you understand the way people think, and ultimately your long-term learning will be better. That's kind of the way I've started to approach it, which was a little bit of a change for me. And so I think, the last question I kind of had on this code review topic overall, because we're coming up on time here, is actually going back to the comment you made about the silos in your team. And do you find that remote work has made that more challenging, especially given the fact that people aren't in the same, location, and maybe, the AWS person is talking to the search person in the office, or have you guys solved that?
My team is a funny beast in that I was in the Seattle office. Now I'm in San Antonio. One person on my team is in London. Two people on my team are in Los Angeles, and one person on my team is in Irvine. So like, even if we were all in the office, you would only have like two of us in the same place. And so because of that, even before COVID, well, independent of COVID, my team is kind of remote first in essence, just because we're totally distributed. And so, like the idea of having us all in the same office is like not even, on my radar, right? So by necessity, we kind of treat everything virtual first, and heavy use of Slack, and heavy use of GitHub and everything.
Got it. I was just curious because I think, teams that were in person that shifted to remote struggle with it maybe a little bit more. I certainly feel like, that is a challenge that I've had to confront, is like, how do you do remote right? because you got it.
Yeah.
And with that, I think that's about all we have today. Thank you so much for joining us, Joel. So many great lessons just about the practical challenges of implementing machine learning. Love talking to you about notebooks. And as always, your sense of humor was hitting today. So thank you so much for joining us.
Thanks for having me. This has been a fun conversation.
Demetrios, any last words?
Yeah, as always, wherever you're listening to us, if it's Apple Podcasts or Spotify, give it a subscribe if you haven't already. And that's all we've got. If you're not in our Slack, you can check out the description to get in it because we mentioned it quite a bit in this conversation. Also, all of the other good stuff that we mentioned in this conversation, we're going to throw into that description so you can see what that tool was that Joel couldn't remember the name of. And you can also see his talk that we referenced quite a few times or his book. And that's all we've got today. Thanks for tuning in.